Now that you have more knowledge about the FM synthesis equation, let's revisit the demonstration called FM Demo 1 and apply some of our new insights. Alright, so I'm beginning with my modulation index set to 0, so that means we only hear the carrier. And as we increase our modulation index, we allow more of the sideband amplitudes to become non-zero. I'd like to have a little bit more ability to see that cluster, so I'm going to reduce my sampling frequency. Same sound, but it just makes it easier to see the spacing of the sidebands. And again, we see that the modulation frequency sets the spacing of the sidebands. Now let's find out a little more detail how modulation index influences the amplitude. Okay, we see a drop in the amplitude as modulation index gets larger from 0. Here we see that the carrier is rather small, but we also start to see that the sideband is actually getting larger. And if you watch how the amplitude of the first sideband varies with modulation index, so again, each sideband amplitude kind of follows its own path based on the sideband number and the modulation index. Now notice that I've got everything kind of arranged so all of these non-zero sidebands are more or less in the middle of our spectrum plot. We have no aliasing evident at the low end or at the high end. As you move the cluster higher, you can actually observe aliasing happening. You can also have aliasing at the low end where, again, we see some of the smaller sidebands are actually intruding, I guess, from the negative side.